artificial intelligence isn't just knocking on the door of medical imaging anymore. I mean, it's already moved in, it started rearranging the furniture.
Right.
We're seeing these AI tools that promise to completely transform radiology, pathology, you name it. But this whole rapid adoption thing has created a massive credibility problem.
A huge one.
Yeah, if a paper comes out and says its AI is 99% accurate at detecting cancer, how do we actually know the research behind that is trustworthy, that it's rigorous, and most importantly, reproducible?
That reproducibility crisis is exactly what we're tackling in this deep dive.
Yep.
Our mission today is to really unpack the checklist for artificial intelligence in medical imaging, the CLAIM 2024 update.
Okay.
And you should think of this document as the scientific community's really strong reaction to all this information overload. It's designed to be the definitive guide for transparency and, frankly, integrity in a really high-stakes field.
And the original claim guideline, that was introduced a few years back, right? It already has some serious traction.
Oh, absolutely.
It was made specifically to promote, complete and consistent reporting. And we know researchers were paying attention. By early 2024, it was cited, over 600 times on Google Scholar alone?
Exactly. And that kind of adoption, it just signals that the community knew there was a serious need for a standard.
So this isn't just a minor tweak then?
No, not at all. In a field that changes almost quarterly, the original guideline just couldn't stand still. So the goal of this 2024 update wasn't simple maintenance. It was a full-scale formal revision using this extremely rigorous expert panel process.
And the purpose behind that?
It's massive. It's about building unwavering trust in published results so these AI models can actually move from the lab where they look great into the clinic where they can safely and reliably help patients. It's an essential educational tool for authors, for reviewers, for everyone.
Let's talk about that rigor, because that's really what separates a suggestion from an actual standard. The Claims Steering Committee didn't just, meet for coffee.
Not at all. They formalized everything by renewing their registration with the EQUATOR Network.
And for anyone who doesn't know, the EQUATOR Network is basically the global organization that exists just to promote these kinds of high-quality, transparent reporting guidelines.
It signals they are dead serious. And the foundation of the whole updated checklist is pure consensus. They used what's called a formal Delphi consensus survey process.
So the Delphi process,
Exactly.
what is that exactly?
It's a highly structured way to get a group of diverse experts to agree on something. You collect their opinions anonymously, you show the whole group the results, and then you ask them to vote again, and you just keep iterating until you reach a consensus.
That sounds like a great way to avoid groupthink. So how diverse was this panel?
It was incredibly broad. 73 volunteers participated, 72 completed both rounds. And that included frontline physicians, radiologists, pathologists, alongside core AI scientists, journal editors, even statisticians.
So you're getting all the different perspectives.
Exactly. It ensures the guidelines aren't just theoretically sound, but that they're also clinically and technically practical.
What strikes me first about the new structure is just how focused it is on accountability. They made one simple change that seems to radically improve clarity for anyone reading a paper.
It's a huge operational breakthrough. Each item on the checklist now uses a new response format. Authors get 3 choices: yes, no, or not applicable NA.
And if you say yes, you have to show your work right. You have to provide proof.
You do. If you mark yes, you are strongly encouraged to indicate the exact page and line numbers where that information is. You can't just say, yep, we did it. You have to show them where.
Right.
But just as important are the no and NA options. The panel knew not every item applies to every study. So if you mark no or NA, you're now encouraged to explain why. It forces the author to justify any omissions up front.
Okay, let's move on to where I think the real fireworks are, the terminology. This is where Claim 2024 just cuts through years of machine learning jargon that's been confusing people.
Yes.
I know a lot of our listeners struggle with the words around accuracy testing. What was the biggest cleanup job in this update?
It's the complete overhaul of how we talk about our benchmarks for accuracy. The claim team is strongly, and I mean strongly, encouraging researchers to ditch terms like ground truth or gold standard.
And replace them with what?
They want everyone to adopt the term reference standard.
But ground truth is everywhere in machine learning. It sounds so definitive. Why get rid of it?
Because it's a borrowed term and it's misleading. It comes from meteorology, where it means information observed directly on the ground, implying absolute undisputed truth.
Ah, I see.
The problem is, in biomedicine, the so-called truth, the label on an image, like this is cancer, is usually an expert human annotation. And that inherently has some uncertainty. That label is our reference, but it's not some kind of divine absolute truth.
So using ground truth basically misrepresents the whole diagnostic process, and gold standard feels kind of old-fashioned anyway.
It is. It's another borrowed term from economics, suggesting a fixed value. But ironically, most economies don't even use the gold standard anymore. The term reference standard just aligns so much better with other guidelines, like the STARD guidelines for diagnostic accuracy studies.
Okay.
It just conveys that, look, this is the best available benchmark we have right now, not that it's unassailable. And this change impacts a whole chunk of the checklist, items 14 through 18, which all deal with how you get and validate that reference standard.
That shift alone is a huge aha moment for clarity. So let's tackle the other confusing term they went after, validation.
Right. They strongly discourage validation because it's way too broad, and frankly, it's confusing. A clinician might hear validation and think it means testing against what's clinically true, when often it just means the model was tested in some way.
So how are authors supposed to describe model testing now?
They have to be very specific. Use internal testing when you're evaluating the model against a held-out chunk of your original training data.
And external testing.
You use external testing only when you're evaluating it against a completely separate external data set. Maybe from another hospital, another country, a different type of scanner.
That distinction, internal versus external, that seems absolutely critical for checking if a model can generalize.
It is.
It gets to that core problem of an AI model that scores 99% at hospital A, but then completely falls apart when you try to use it at hospital B.
Exactly. If we want AI to work for everyone across diverse populations and different hospital systems, external testing is it's just not optional. And they're not banning the word validation, but they're urging authors to use it with extreme caution.
Yep.
Better to use specific terms like tuning or model optimization.
Okay, so that moves us logically into the methods section. If we agree on the language, the next fight is over the building blocks. Let's talk about the data itself, the core of reproducibility.
Right.
If I want to rebuild your AI model, what specific details do I need now under Claim 2024?
Well, we start with the images themselves. Item 13 is a new addition, and it mandates a really a forensic level of detail on the image acquisition protocol.
Why was that so important to add now? I mean, isn't we used an MRI scan good enough?
It's absolutely not. The panel added this because these AI models are incredibly sensitive to tiny changes in the input data, a difference in the specific MRI sequence, a slight variation in CT energy, a change in slice thickness.
Okay.
All of that can dramatically alter the texture features of an image. And those are the very things the AI model is learning to see. So if you just say, we used an MRI, but don't list the manufacturer, the sequence, the resolution, I have zero chance of replicating your findings.
So the input is as important as the model architecture. Now, what about data leakage? How do we prevent that from artificially inflating the scores? Items 19 and 20 are about partitioning the data.
Yes, authors have to specify exactly how the data were split up. Training, tuning, testing, and justify the ratios, like 8, 10, 10, and 10.
Yeah.
But the really critical part is describing the level at which those partitions are disjoint.
And the consensus on that was that image sets must be disjoint at the patient level or higher. Why is that so important?
Because it's the difference between testing the model's intelligence and just testing its memory. If you split your data at the image level, you might accidentally have, say, an initial scan and a follow-up scan of the same patient in both your training and your testing sets. The model sees that patient during training. It learns their unique biological quirks, maybe scanner artifacts.
So it's not learning to detect the disease, it's learning to recognize that specific person.
Precisely. When it sees the test image, it's just recognizing a familiar pattern from a familiar patient. That artificially inflates your performance. By forcing the split at the patient level, Claim 2024 makes the model generalized to someone it's never seen before.
So once we have the data integrity locked down, the next big question is model transparency. How much of the secret sauce do authors actually have to reveal?
For any new model architectures, the bar for transparency is now set extremely high. Item 22 says authors must provide a complete and detailed structure of the model.
So all the inputs, outputs, layers.
Everything. Enough detail for someone to reconstruct it exactly. Or, even better, they should just provide it as a supplemental code.
I can already hear the pushback from proprietary AI developers on that one. I mean, that's demanding full disclosure of their IP, isn't it?
It is. And that is absolutely where the tension lies between open science and corporate innovation. But the consensus is, if the field is going to move forward reliably, We can't have these black boxes.
And item 25 is just as demanding about the training process itself.
Yep, you can't just say we train the model anymore.
That's where we get into all the hyperparameters, right?
Exactly. Think of the AI model as the cake, and the hyperparameters are the specific settings on your oven, the temperature, the cooking time. Item 25 requires full documentation, augmentation methods, how you monitored for convergence, and then the specific hyperparameter values, the learning rate, the optimization algorithm, mini batch size, all of it. Without those settings, even with the code, I can't replicate your results.
That's a key point. The details matter more than the big picture. I did notice one item was deleted from the original checklist, item 11, about data dictionaries.
Yeah, that was removed based on panel consensus. It was just deemed overly burdensome and complex for a lot of existing clinical data systems. A practical simplification. And similarly, the committee also made a deliberate choice not to extend the checklist to things like radiomics or pathomics. They're keeping the focus laser sharp on full AI models for medical images.
All right, let's shift to the final section. Evaluation and clinical translation. We have this well-trained, transparent model, but does it actually work in the real world?
And that's the whole point of this section. Item 33 really puts the hammer down on the requirement for external testing. If you use external data, you have to describe it completely. And if you don't do external testing, you must explicitly note that and justify why it's a limitation.
It's a push away from siloed data sets.
Exactly. It's all about generalizability.
And when reporting results, it seems like there's a huge new focus on identifying potential biases, not just proving accuracy. This speaks right to the equity challenge in AI.
Absolutely. Items 35 and 36 bring in mandatory transparency about patient demographics. You have to document who is included and excluded, often with a flowchart. But the critical part is that you have to specify demographic characteristics, age, sex distribution, underrepresented groups in every single partition. Training, tuning, and testing.
Why in each partition?
Because that's how you spot bias before it hurts someone. If your model was trained on a data set that was 90% white male patients, but your test set is diverse, you've introduced a serious bias that needs to be discussed as a limitation immediately.
It's about moving toward greater equity and safety.
Right. And item 39, failure analysis, is also vital for that. It asks authors to help people understand the incorrect results.
It is probably more important to a doctor than a high accuracy score.
Arguably, yes. A high score doesn't tell a doctor when the model is most likely to be wrong. So you have to provide things like a confusion matrix. And more than that, the guideline strongly recommends presenting actual examples of incorrectly classified cases, show the image where the AI failed, and discuss why. That's how you clarify the tool's real-world strengths and weaknesses.
And that leads right into the final crucial step. Item 41, implications for practice. The big so what?
The authors have to describe the intended use, the specific clinical problem the AI solves, and its potential role. And they must also explicitly discuss any practical roadblocks to getting it into daily practice. Does it need special hardware? Does it mess up existing workflows? It's about managing expectations.
And finally, that commitment to open science is cemented in item 43.
Yes. Authors are required to state exactly where people can access the software, the trained model, the data, including any conditions for access. And they were strongly encouraged, and this is the real push, to deposit all their code into a public repository like GitHub. The whole principle here is moving toward maximum availability to promote reliability.
So to synthesize this massive effort, Claim 2024, coming out of this intense, consensus-driven process, is fundamentally changing how we report on AI in medical imaging.
It is.
It's forcing us away from ambiguous old terms like ground truth and replacing them with the scientifically rigorous reference standard. And crucially, it's enforcing that clear separation between internal testing and the essential real-world measure of external testing.
It's really the necessary structural intervention to ensure we get consistency, transparency, and true reproducibility. At the end of the day, it's about safeguarding the reliability and clinical safety of models meant for patient care.
And that leaves us with this final provocative thought for you to explore. The 2024 update puts such a massive structural emphasis on the public availability of detailed protocols, code, trained models, everything. How might this comprehensive push for maximal transparency and open science fundamentally alter the competitive and often proprietary landscape of AI development in the highly lucrative multi-billion-dollar field of medical technology? What will maximal transparency cost the corporate innovators, and will the demand for reliability win out over the desire for profit?